So many thanks, Neil. Yeah, I think it's a privilege for a professor to be here all this year. It's one of these very nice events of every year. So I'm very grateful to Rodolfo that invited me 30 years ago. But now it's the time to pass this privilege to more younger professors. I think it's fair. So I'm going to talk about epidemiological research and translation to policy, so to interventions, to regulations. And I choose these topics that crossed my life. Air pollution have been always in my life. He pursued me, and the brain. And I think I should use this. Yeah, I like very much this picture. So this photograph, is of the Earth from outside the atmosphere. And the first time that it was taken was around 70 years ago. And I like to think that this photo changed somehow the perception of the humanity about themselves and the perception of the fragility of the Earth. No? And what's true is that this photo precedes for a few years. So for instance, the creation of Greenpeace, or the creation of the Environmental Protection Agency, or the concern by the economies of the Club of Rome about the limits of the Earth resources, or even the concern in the United Nations conferences about the protection of the Earth. So I like to think that there is like a relationship. But what impressed me a lot is that 500 years before, Bramante, that is a painter from the north of Italy, painted this picture with two Greek philosophers from 5 centuries before Christ, with the Earth in the middle. So it's like the abstract thinking, the reasoning advanced the technology of this and the science for many, many years. And actually, this is what happened with air pollution. So in 1661, a poet from England sent this letter, Fumifugium, to the king, advising him in a poetry as how the sea call, that actually it seems that was a call from Newcastle, was so dangerous for the coughing. And in this, with poetry, he described the Greek concern from Hippocrates about the pollution of the air as a cause of diseases. And then he also makes some proposals to the king how to improve the quality of the air. And he suggested to green London 300 years before. So actually the fiction precedes the scientific evidence. And this is true. Look, it took 300 years until December 1952 that we have the first data. Well, the first data with reasonable numbers. Oh, this is London fog, sorry. It's missing the F. So there were repeated episodes every winter, or every 2 or 3 years winters, of what's called P-Sapper fog. In that case, they closed the opera, they closed the cinemas because you couldn't watch the movies. And actually, what happened this time that was different from previous, by the way, the Londoners think that this this fog was related to humidity, and the increases in mortality during these episodes that they already know were related with humidity and cold. But at that time, the Ministry of Environment had a device that was able to measure every day the amount of particle. In that case, black smoke. That is near a quasi ultrafine particle that came from the coal. So they have the daily number of deaths that in 2 weeks accumulate 4,000 above the expected. So this was a massive epidemic. And they have the two time series, the time series of the air pollution and the time series of mortality. And this was the first data that we have. By the way, there was not a translation of this data on changes in intervention until 10 years afterwards. So although here we have the first scientific evidence, the first data, still it takes more time. And there were as many epidemics that serve to develop the methodology. There were proposals like this one. A pulmonologist, Lothar, with Robert Waller from the, and at the time they worked in the Department of Environment, that followed 185 patients from Lothar, a pulmonologist. And Lothar gave a logbook, a book, to the patients, and every day the patients have to fill in if they feel better, worse, or equal than the day before, and if they have more or less medication the day before. So this was a multi-level model, a multi-level design, named panel study. But at the end, this was analyzed as a time series. So at the contextual level, they pull all the 185 scores, and they look at the association with the daily variations on air pollution. And this was like an episode occurring like 5 years or 3 years after the 52. And it was 62, when there was another big episode with more than 700 deaths above the expected, when they launched what is named the Clean Air Act, that moved away the polluted industry, changed the origin of the coal, etc. So, yeah, epidemics are related with more research, development of designs, and translation. And this is interesting because in our course, we teach about the designs to study the acute effects of transient exposure in transient effects that are not the common designs in epidemiology. And probably this was the first time series study. And actually, if we go to PubMed today, and you click air pollution and health, you will see that there are 53,000 papers. And if you add time series, there are 5,500 time series studies in the literature since the 52 that are more than cohort studies. So we have nearly 5,000 papers on cohort study in air pollution and health. The difference is that time series study the acute effect, how the air pollution of today is going to affect your health tomorrow, or today and tomorrow, not the cumulative exposure. And this was originated, I think, in this epidemic in London. I borrowed this from my friend and colleague Nino Kunzli, that, by the way, we have working together many, many years. And it's funny that we retired also the same year. So he did this slide that it came from NIH in 2002. And this was a meeting of experts on air pollution and health. And according to their view, the amount of effect due to a transient, so here we see the life course of three people. One that is not polluted, then we expect cumulatively exposed to air pollution, and this third was one that has a similar trajectory than the second one, but also is affected by a sudden episode of air pollution. And according to this committee, the amount of the effect of the cumulative exposure to air pollution could be as high as the amount of effect from a transient episode. So acute effects also could play a role in the impact of air pollution. But this was named black box epidemiology, and no one believed in time series. So what's important were the cohort studies. And actually, probably this was a seminal paper, the 6-city study paper in Massachusetts comparing 6 cohorts, 6 cities. So they discovered that at a time that the air pollution levels were much, much lower than in the 50s in London, where the levels were micrograms. So there was a change of 3 digits, 100 times with exposure in London. So at these very low levels, still when we compare these 3 cohorts that they pretend that they adjust for all the confounders, so the people are equal in everything except on fine particles less than 2.5 microns, there was a 30% increase in mortality for people living in that city compared to the people living in this city. And nobody could understand why, because at that time there was the knowledge that air pollution only affects respiratory diseases. And this was a lot to be explained just by respiratory diseases. So they put a lot of money, the agencies, to understand why air pollution is going to have this big impact in health, if this is true or not. And actually, there have been, as I said, 60,000 papers, and some very important research, like this one, that was a pre-post study. So this study assessed the most important American cities. And what happened in the States that since the 80s, it started to decrease the air pollution because there were interventions in the industry, but also in the cars, so especially in the trucks, that they put filters in the trucks. So there was a decrease, a reduction in the fine particles in all the cities. And what they saw is that for 10 years, the amount of reduction in particles per each one of the cities, so almost in all cities there was a reduction, except this one, the amount of reduction in particles was related with the increase in life expectancy. And what is interesting is that these 0.6 years of increase in life expectancy in 10 years was similar to the increase in life expectancy, according to a paper in health economics, the increase in life expectancy due to the improvement in new drugs, in new medication. So they said that interventions like reducing 10 micrograms of PM2.5 could increase by 1 year's life expectancy. There are other studies, like the children's health studies in Los Angeles, that found the same. In that case, this was a study that combined several cohorts of children with thousands of children followed every year. And they recruited the cohorts during this period. In Los Angeles, first they started to remove the refineries, the petrol industry outside the Los Angeles, but the decrease was not very large. It's until they started to intervene in the traffic, especially the trucks and also the highways, that they found a dramatic change in the cleaning of the air. So what they found also is that in these children, here grouped by their city or their area within Los Angeles, the amount of reduction in air pollution was related with the reduction in respiratory symptoms. And also, and for me more important, because lung function is an objective measure and they affect all the population. When they look the different generations that were exposed correlatively to lower air pollution, they found that, for instance, the prevalence, the proportion of children that crosses the threshold of definition of bronchial obstruction decreases from 8 to 2 or 8 to 2.5. So more than 3 times decreases the proportion of children with obstruction if we're born in a generation with cleaner air. Yeah, so the evidence starts to be very consistent and very robust in terms of causality. What the last year have focused is to understand if at very low levels there are effects. So this paper from American cohort, I don't recall now the name of the American cohort, on fine particles and coronary artery calcification progression, show an association at very low levels. And this is now one of the focus of research. What is the limit? What is the threshold in terms of intervention? Another issue of interest is whether this is multi-organic and affects many other organs than the classical ones, the respiratory and the heart and the lung cancer. So now, and there are both, we have evidences that are considered already causal for many other organs, especially the prenatal effects on reproductive outcomes and fetal outcomes. But also the brain, like the neurodegenerative diseases. So there are now hundreds of papers, and very recently there was a very important review in the Lancet on Alzheimer and air pollution. So what we know, I think now we are very certain that air pollution produces a multi-organic effect, very similar than smoking, no? And in fact, the mechanisms are also similar. It's related with oxidative stress, like early aging, no? Reduction of the life expectancy. That this is at lower levels than expected. That is mostly related with fine particles and to less extent to gases also, but with a difference of 10 times. And that is, at least in the urban pollution, that is related with traffic, especially in Europe, but also intensive agriculture, especially in China and all over the world. Is even more important, the intensive agriculture. And industry has become a lesser cause of this. So what has been the milestone, the impact of these 56,000 papers? One, that the GBD, at the beginning also in 12, this is GBD 13, already classified air pollution as one of the top determinants of mortality. And also that they show that the air pollution is among all the so-called environmental factors the first determinant of mortality, more than 8 million, 9 million. And that the area most affected for this are Africa and Asia, especially South Asia and China. They have other impacts, I think, quite important. There was this debate within the United Nations whether the SDG, the Sustainable Developmental Goals, are feasible or not. And they organize, because, you know, the Sustainable Developmental Goals have this inequality among them, that economy prevails. It has a higher importance than the rest of SDGs, health or ecology or poverty. So, and there are many practical issues also about the application of the goals. So they organized this group of experts that were all scientists that launched in 2000, just before the epidemic, this advice how to reorganize the SDGs in the way to improve the efficiency of the interventions. So they came out with this idea to focus in just 6 main actions. And the proposal is that they have to be based, the intervention, in the scientific evidence, in the data, and after putting together the power, the governments, the economical sectors, and the society. And what's interesting is that among these big strategies to transform the world in the way to achieve the SDGs, in addition to food systems or the energy decarbonization, included the urban and peri-urban development, with a strong focus on improving the air quality of the cities, and also the decrease of the noise and other issues. No? So this is another achievement, I think, of this research. And of course, another achievement is the restriction of the standards. So the regulation, to tightening the regulation. And the first regulation was, the first proposal of air quality guidelines by WHO was done in 1987, so many years after the London episode. The last was done in 2005, and now we have a new one. So they have a reduction in what WHO agrees that is not a threshold of not protection of the health. So, sorry. Now the annual level for NO2 that WHO advised is this amount. I have to say that in states, the standard, so this is the result of the risk assessment of the literature. And this is what WHO, so the health sectors, advise. But the risk management is what the governments regulate. And it's important to know that although WHO advised these levels, the standard in European Union is 25. And even there are many cities in Europe that do not achieve this standard yet. And many in the world, of course. And it's even more important, the reduction proposed for NO2 from 40 to 10. Let's see what the European Union will say. But again, still in the world, there are many cities that do not achieve the old standard. No. But these are achievements to see that we have to clean the city in a more stronger way in order to improve health. So what are the milestones from these last 10 years, I think? So in 2014, WHO accepts that air pollution is the first environmental determinant, declares so. And World Bank also agrees on that and estimates the direct cost in trillions. What I explained about the future of is now, I think this is a big achievement that includes urban redevelopment as one of the 6 strategies to achieve SDGs. Confinement shows that indeed we could decrease the air pollution levels. And all over the world, confinement, due to the COVID epidemic, declined dramatically the NO2 levels. Though the levels of fine particles were just moderately declined. And this was because of the particles that came from intensive agriculture that contain ammonium and that, travel into the cities. And finally, just last year, there was this reduction of air quality criteria by WHO. So, there is need to do more research. That is what I'm doing. I was asking myself about that. Why a new time series study if we have hundreds, thousands of time series studies? So I'm just going to spend the last 10 minutes to talk a bit about my concerns and a little about my research. I was hooked in this study of air pollution and brain by this woman, Lilian Calderon, that is a pathologist. And in 2008, she discovered, so she did pathologies of the brain, of autopsies, first of dogs, in an area of high pollution in Mexico City and an area of low pollution in Mexico City. And she found was a change, an inflammation in the prefrontal cortex that was very similar to what happened in Alzheimer's. And then she did studies also in autopsies of children and found the same. At the point that in 2013, she publishes this paper, Early Alzheimer's and Parkinson's Disease in Urban Children. So she was the first who suggests that the brain also could be affected by particles through the olfactory nerve, through the direct translocation from the lungs to the brain, through the molecules that the lung creates that could be also affecting the microglia. So there were also some laboratory studies in rats exposed to diesel particles that showed the same inflammation in the brain. So with this data, I did an epidemiological study, probably the first with these numbers. And I did an epidemiological study in children in schools, basically for feasibility reasons, to get large numbers and to be able to objectively measure the cognitive development in school children with a series of tests and to see the growth of the brain through the growth in performing the cognitive test. And we install monitoring cabins inside the classrooms and in the courtyards. And we choose 40 schools that we try to pair from high and lower pollution within the city and with similar socioeconomical conditions. But we have, of course, adjusted for the ecological and the individual socioeconomical factors. Though I must to say that in cities like Barcelona, but Barcelona is not only the only one, Rome or even Paris, air pollution is higher in the wealthy population than the poorer population, because wealthier people live in the center of the city, where is more air pollution. So if there is a confound, it's in the opposite way. So what we found, so this is 1 year, this is the growth of the brain in that age. We expected that growth, the working memory, and actually growth. But it grows in a different way. This is summarized. The schools in the high traffic pollution and the schools in the low traffic pollution. So there was a lower increase in the development of the brain. And we did in 300 of the children MRIs. And actually, we didn't find any structural change in the brain comparing children according to their pollution levels at the school. But in functional MRI, that you take 150 images and you look if the function, how these images progress is related with the air pollution. We saw a similar imaging comparing the children with higher pollution and lower pollution than what we also saw in other studies and in this study in relation to age. So these children were resting, but the brain, when it's resting, also doing nothing, also is working. So the ability of integrate their activity is improving by age. So there is an opposite. So the findings, it was like the maturation of the brain was delayed. So we didn't find at the end a very severe effect of air pollution, but a functional effect that could be probably reversible. And in fact, we did another finding. When we look at the greenness of the schools, we also found a similar pattern than for air pollution. And 70% of this pattern is explained by air pollution. But what we found that was very interesting in greenness is that we could reconstruct for each one of these 3,000 children their exposure to green spaces at home, because one could accept that during 8 years the vegetation around your home will be more or less similar. And what we saw is that the greenness at your home during your early life was actually related with profound changes in your brain, with structural changes in the brain. So these results led me to think that, yeah, perhaps we need to go to the early life, because perhaps, like in the case of greenness, it was when the window of susceptibility is more important than at ages 7 to 10. Well, something that we did at that time is also to write a paper on how to protect school children from the neurodevelopment, and we suggest several interventions. And in that case, the city council, did some changes, very modest changes, just in 30 cities, in 30 schools, though they promised to do this in 300. But they reurbanized one of the traffic lanes in front of the schools. They decreased the speed around the schools. So we have had some impact. Other cities believe more the results, like London, where these interventions around the schools were much, much larger. They did in hundreds of schools and in a more profound sense. So they just not reurbanize one traffic lane. If not, in some schools, they create a non-emission zone around the school. And even in Paris also, with funding from Bloomberg, they ranked, so they measured their pollution in all the schools, and they ranked the schools according to their pollution level to choose which intervention should do. On other cities, based on this study, also make changes around all the cities, like Bilbao. And actually, the debate is why to do these small interventions around the schools if we know that we have to do big interventions to achieve the WHO quality standards, because then we also will protect the schools. So, but since this is not done, well, welcome these small interventions around the schools. Okay, so I was motivated, and I think this is a pleasure of research. So why you do more research? Well, also because, yeah, there is a pleasure, there is curiosity, and yeah, although the goal is to change and to improve the health of the population, and there is also this type of motivation. So I followed this interest to understand if these findings were reversible or not, and I think I should go to early life. And in fact, what we did is also using modeling maps of the city to reconstruct the air pollution exposure of all these 3,000 children since their pregnancy period. And actually, what we found is that when we look at the prenatal exposure to air pollution at home of these children, with the MRIs taken at 9 years old, we found an effect in this tract that is the largest white matter tract in the brain that connects the two brains, named corpus callosum. And children with higher air pollution have a smaller corpus callosum, higher air pollution prenatally, and corpus callosum 9 years afterwards. Of course, we did this retrospectively, and we are not very sure if we do a good measurement of the exposure. And in fact, when we apply this distributed lag modeling in our children and look cognition, we saw that there was an effect of the exposure to air pollution before the cognition assessment, the cognitive assessment, that is what we already found, but also with exposure early in life. So then I planned another study and yeah, developed a new cohort named BISC with more than 1,000 children and a lot of prenatal imaging and a lot of effort to have the best possible exposure assessment. And the idea was this one. And these arrows, yeah, represent the amount of evidence in the literature. So this is pregnancy, and we are interested in the child and the brain of the child. But there are several steps. So the mother breath, the particles, but also we are interested in noise and greenness. And this goes to the bloodstream of the mothers and to the organs of the mothers. And there are several pathophysiological hallmarks that could occur, and there is evidence about that. Though all the potential arrows that you could figure out, we don't have any evidence at all. So it could have that these changes, physiopathological changes in the mother, affect the quality of the placenta, or directly affects what we name intrauterine growth retardation and the fetus. So there is then this barrier, the placenta, and also directly the particles, because there is some evidence that there is particle deposition in the placenta, could affect the function of the placenta and their pathophysiology. And this is going to affect the growth of the child, and is going to affect the brain of the child. And we are measuring this with intravaginal neurosonography, and we are measuring the placental function with Doppler tests. And we want to see if this prenatal exposure is affecting the brain already in the third trimester of life, and in the neonatal brain, and the brain at 1 year and a half. So why to do this research again if we have enough evidence for the interventions? No? And in fact, well, so I do classical epidemiological research. And this is a very nice theoretical frame developed by my colleague, Mark Newhausen, that speak about the causes of the causes. No? And yeah, my research is in that area, from the pathways to neurodevelopment in that case. But probably for the sake of intervention, yeah, we have to go to the causes of the causes, because intervention should go in that direction, in urban redesign. And actually, there are many cities in Central Europe and North of Europe that have done this. And each one has one preferred city, no? And this, for me, Utrecht is one of these good examples, no? They started in '73 with the petrol crisis to buy, but still within the cars. And this is the same square now, but it's forbid any car in the square and among all the center of the cities. And they transformed the parking in front of the station with on a parking for bicycles, or they covered the old highway that crosses the city in that way, where the private traffic has a small piece of the space. So there is still a lot of space for green, or for the pedestrian, or for active transportation, or things like that they have an epidemiology in the department of in the city council department of urbanism that evaluate the impact, the health impact of any re-urbanistic proposal. So this is the way to transform, I think, the reality based on the epidemiological evidence. So I finish with this slide from this fresco, where I think Platon is pointing to the spirit, to the sky, in that case to the brain, and is telling Aristotle, oh, why are you doing more research if we have done enough? And what matters now is to do intervention, or to do research on the evaluating the interventions. And Aristotle said to Platon, "Oh, touch on earth." And you know, the humans are a bit stupid, and with reasoning is not enough. We need to provide empiric data. We need to provide evidence, narrations to convince the humanity that actually they need to do interventions, and one after the other. So there is not enough with just the reasoning. We need to provide data continuously. So this is what I wanted to say.